Seems to be a big question on everyone's mind is, can you convert methylsulfonyl methane to a sulfur source that's going to feed hydrogen sulfide production in the gut? Let's get into it. What I've got for you here is a list of the microbial species that are capable of making hydrogen sulfide gas and the substrates that they're able to use in order to do this. So you'll see in this list we have sulfate, we have sulfite, we have cysteine, we have sulfomucin, shedding off of your gut lining, we have taurine, we have sulfated bile acids from a rat model, and we have estrogen 3 sulfates and phenyl sulfates. So those are the lists of sulfur sources. You can see that methylsulfonomethane is not in that list. So in order to create hydrogen sulfide gas, you're going to have to somehow turn the methylsulfonomethane into one of those compounds. What I can't find is any conversion that does that in the gut. For the most part, methylsulfonomethane is absorbed intact, passive diffusion, and is distributed throughout the body in every single tissue once you ingest it, and it gets across. So now what I've got here is a more simplified version of the same story, and it's showing that there's an internal production of hydrogen sulfide gas for everyone, and that's formed from the shedding of the sulfated mucus and the bile that's being released from your gallbladder mixing with taurine, and the bacteria can use that to make hydrogen sulfide gas. That's apart from your diet. Now, with your diet, what you're going to need is the sulfur-based proteins, which methylsulfonomethane is not, and sulfite, which methylsulfonomethane is not. So I'm highly doubting that this is possible, that that's what's happening for people, that they're not using methylsulfonomethane in the GI1 powder to create hydrogen sulfide gas. And furthermore, hold on to your hats for this one. I found this article that was done on chickens, and they were looking at adding MSM to the diet in various concentrations and what was the effect on the microbiome and on intestinal gas production. This is going to blow you out of the water. Okay, so you can see that as they increase in the concentration, right? So the CON means control group, and then S1, S2, S3 are increasing concentrations of added MSM into the diet. Now the lactobacillus species with increasing concentrations went from 7.58 to 7.70. There was an increase in the lactobacillus species. The E. coli, which is what we want to impact. I mean, Xifaxan is a drug for E. coli, right? That's where it all started. So this extrapolation into other species is new. It started out as a drug for E. coli to treat E. coli conditions, right? Traveler's diarrhea, irritable bowel syndrome, D diarrhea, and hepatic encephalopathy. The extraction into SIBO is a whole different animal. E. coli species, control group, 6.63 concentration, and that's in CFUs per gram. Increased concentration to the highest dose, and the numbers drop to 6.26. Okay, so increase in lactobacillus species we want, decrease in E. coli species we want. All right, furthermore, when they looked at gas production, and here's the hydrogen sulfide gas. So in the control group, 2.6 parts per million. And when you go higher in concentration, guess what happens to the hydrogen sulfide gas? It decreases. It goes from 2.6 in the control group to 2.3 in the highest concentration that was tested. So we've got some information here. You know, let's not jump to conclusions, but so far I've yet to find a pathway that shows that methylsulfonomethane converts to hydrogen sulfide gas. And I don't think that's what we're really doing with my protocol. I think what we're doing is potentially replacing a deficiency of sulfur in the body. That's internal upregulation. In the gut, what we're doing is we're having an antimicrobial and antifungal effect and healing effect of the tissues. And I've got other videos that cover that.